In this video, we're going to talk about finding and defining parts of a polynomial function graph. So we're going to be finding y-intercepts, x-intercepts, maximum, minima, increasing intervals, decreasing intervals, positive intervals, negative intervals, and defining the end behavior. So our first example, we're given the function f of x equals 3x minus 2 and x plus 2 squared. So to find all these parts of the graph, we're going to be using Desmos. So let's first type into Desmos the function 3x minus 2, close your parentheses, x plus 2, and we're going to square it. Okay, let's zoom in a little bit. So we have a 0 and a max at -2, 0, a min, a y-intercept, and another x-intercept. So let's just click on all these different parts and start typing in. We have a y-intercept. So the first thing we want is a y-intercept, and that's just 0, -8. Okay, let's go back to our graph. Now at the x-intercepts, we have one at -2, 0, and the other one is going to be at 0.667, 0, so we'll write those in. So -2, 0, and 0.667, 0, which the decimal's fine, or you can just convert that to 2/3, but we'll just leave it the decimal form. Okay, next thing we want is our maxima. So we have a maxima at -2, 0. Next thing we want is our minima. That's -0.222, -8.428. So -0.222, -8.428. Now we want our increasing intervals. That deals with our maxima. So let's just use our highlighter. So we want the x value of the maxima. So we start increasing from -infinity to -2. So we'll just highlight our first one. It'll be -infinity to -2. Then we switch from increasing to decreasing. So from this deals with our minima, so it's going to be -2 to -0.222, and that deals with our minima. So I'll just highlight that one. So this goes from -2 to -0.222. So we have our minima and we have our maxima. And then looking at the graph again, we increase from -0.222 to infinity. So we just keep on increasing after that. So now we switch from -0.222 to infinity. And the -0.222 is our minimum. And we're done. Okay, positive intervals. They deal with our zeros. So let's just grab a different highlighter color. We'll highlight those in blue. So looking at the graph, 0 is technically not positive or negative, so our first negative interval is going to be from 0 to -2, because 0 is technically not positive or negative. So we're going to go from -infinity to -2. And then we're going to continue going from -2 to what do we break the x-axis? We break the x-axis at negative 0.667. Negative 0.667, and these should be negative intervals, by the way. So let's just fix that. Negative infinity to negative 2, and negative 2 to negative 0. Or positive 0.667. Positive 0.667. So these are our negative intervals. And again, those are using our zeros. So we broke the negative intervals into two parts because if we take a look at the graph, at negative 2 we're at 0, and 0 is neither positive or negative. Okay, for positive intervals, from negative 0.667 onwards, we're above the x-axis. So that's our positive intervals. So it'll be from negative 0.667 to positive infinity. Okay, now the end behavior. If we look to the left, as x approaches negative infinity, it's going down towards negative infinity. And to the right, as x approaches positive infinity, it's going up, so it's going to approach positive infinity. So the graph in general looks something like this. So we say as x approaches negative infinity, f of x approaches negative infinity. So in other words, to the left, x approaches goes down. And as x approaches positive infinity, f of x is going to approach positive infinity. So this is the left. This, in other words, left. This means goes down. And this means right. And as approach positive infinity means goes up in general. And we're done example 1. Example 2, we're given the function x to the 4th minus 34x squared plus 225, and we're being given the same task to find the y-intercept, x-intercepts, maxima, minima, increasing intervals, decreasing intervals, positive intervals, negative intervals, and the end behavior. So again, we're going to be using Desmos. So let's first clear out the old function from example 1, and we're just going to type it in. X up to the 4th minus 34x up to the 2nd plus 225. So this function, we need to fix the window sum so we can see the full function. So we can see it. Now let's fix our x coordinates. So let's change our x axis from negative 10 to positive 10. Now we can see more of our function. Again, to change that, the window, we just hit the wrench. So we have a 0, a min, another 0, a max in our y-intercept, a 0, a min, and another 0. So let's use this information to help answer this question now. And I'm just going to click off all these points. So our y-intercept is just going to be 0, 225. Going back to our graph. Next we want our x-intercepts. We have negative 5, 0, negative 3, 0, 3, 0, and 5, 0. Negative 5, 0, negative 3, 0, positive 3, 0, and 5, 0. We have a max at 0, 225, the same as the y-intercept. We have mins at negative 4.123, negative 64, and positive 4.123, negative 64. Now let's handle our increasing and decreasing intervals. So we start by decreasing from negative infinity to negative 4.123. That's using our minimum. So negative infinity to negative 4.123. And then we go from decreasing to increasing to our max, so negative 4.123 to 0. Negative 4.123 to 0. And this is using our min. This is using the x-coordinate of our max. Then going from right to left, we go from increasing to decreasing, so from 0 to positive 4.123. So from 0 to positive 4.123. This is our max, and this is one of our minimum values. So we're just using the x-coordinates. And then if we look at our graph, from 4.123 to in positive infinity, we're increasing again. So let's write that down. 4.123 to positive infinity. And 4.123 is one of our minimums. Now our positive and negative intervals are going to deal with our zeros. So again, we're going to highlight those, the x-coordinates in blue. So looking at the graph, we start positive. So from negative infinity to negative 5, we're positive. So from negative infinity to negative 5, we're positive. Then we switch to negative. From negative 5 to negative 3, we're negative. So negative 5 to negative 3. Then we switch from positive to negative. So from negative 3 to positive 3, the graph's above the x-axis, so we're positive. So negative 3 to positive 3. And then from positive 3 to positive 5, we're below the x-axis, so we're negative. So positive 3 to positive 5, we're negative. And then our last interval, from 5 to positive infinity, we're above the x-axis, so we're positive. And we found our positive intervals. Now we just need our end behavior. So the graph looks something like this. So as x approaches negative infinity, or in other words on the left, f of x approaches positive infinity, which means it's going up. As x approaches positive infinity, this is going to be on the right side, f of x is still going to approach positive and infinity, so that still means it's going up. And we are done example 2. Hopefully this helps you have a better understanding on how to find y-intercepts, x-intercepts, max and mins, your increasing and decreasing intervals, positive and negative intervals, and behavior. In other words, just analyzing your polynomial function graphs.